Good morning, students. I am Savita B, working as Associate Professor in the Department of Mathematics. In this video, I am going to explain Gauss Seidal iteration method to find the solution of linear simultaneous equations. This video is useful for 5th semester BSc students. Now, Gauss Seidal iteration method is a modification of Jacobi's iteration method, Gauss-Jacobi's iteration method. This method starts from an approximation to the true solution and obtain a better and better approximations from a computation cycle, repeated as often as may be necessary for achieving the desired accuracy. Being an iterative method, the amount of computation depends on the degree of accuracy required. Now, since this is a modification of Gauss-Jacobi's method, the convergence in Gauss Seidal method is faster compared to Gauss-Jacobi's method. So, let us understand Gauss Seidal iteration method. Consider a system of equations a1x plus b1 into y plus c1 into z is equal to d1. a2 into x plus b2 into y plus c2 into z is equal to d2. a3 into x plus b3 into y plus c3 into z is equal to d3. We have three equations in three variables, namely x, y, z. So it is required to solve these equations using Gauss Seidal iteration method. Now we rewrite the equations in the form a1 into x is equal to d1 minus b1 into y minus c1 into z, or x is equal to 1 divided by a1 multiplied by d1 minus b1 into y minus c1 into z. Now from the second equation, b2y is equal to d2 minus a2x minus c2z, or y is equal to 1 divided by b2 multiplied by d2 minus a2x minus c2z. And from the third equation, c3z is equal to d3 minus a3x minus b3y, or z is equal to 1 divided by c3 into d3 minus a3 into x minus b3 into y. Now, observe, if a1, b2, c3 are large as compared to other coefficients, then we use Gauss Seidal iteration method and we rewrite the equations in this form. Otherwise, we interchange the equations and see that these diagonal elements are large as compared to the other coefficients. Okay. Now we begin with the initial approximation x0, y0, z0. That is, x is equal to x0, y is equal to y0, and z is equal to z0. Okay. Then we substitute y is equal to y0 and z is equal to z0 in the first equation. Okay. So we have these equations. We put y is equal to y0, z is equal to z0, and obtain x1. That is the first approximation to x, which is denoted by x1. In the second equation, we substitute x is equal to x1 and z is equal to z0. Whereas Gauss-Jacobi methodally, x is equal to x0, z is equal to z0 substitute ಮಾಡ್ತಿದ್ವಿ. ಆದರೆ Gauss Seidal iteration methodally x is equal to x1, z is equal to z0 substitute ಮಾಡಲಿಕ್ಕಿದೆ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ x is already calculated. x is equal to x1 already first equation ಇಂದ ಸಿಕ್ಕಿದೆ. Therefore, we substitute x is equal to x1 and z is equal to z0 in the second equation and obtain y is equal to y1. In the third equation, we substitute x is equal to x1 and y is equal to y1 and find z is equal to z1. Okay, so this is the first approximation to x, y and z. Now in the second iteration or the second approximation, we substitute y is equal to y1, z is equal to z1 to find x2. So second iteration is, we put y is equal to y1, z is equal to z1 to get x2. In the second equation, we substitute x is equal to x2, z is equal to z1 and obtain y2. Third equation, we substitute x is equal to x2, y is equal to y2 and find z is equal to z2, right? So this is the first iteration and this is the second iteration. We continue this process till the values of x, y, z are obtained to the desired degree of accuracy. Now, since the most recent approximations of the unknowns are used while proceeding to the next step, the convergence in Gauss Seidal iteration method is twice as fast as Jacobi's method. I hope it is clear. Let us understand the method. We begin with the initial approximation. Y is equal to y0 and z is equal to z0 and find x1. Then in the second equation we substitute x is equal to x1 and z is equal to z0. In the third equation we substitute x is equal to x1 and y is equal to y1 and continue the process. So recent approximations are used while substituting the values. Okay. So this is Gauss Seidal iteration method, in which the convergence is faster compared to Gauss-Jacobi's iteration method. So we stop the process when the desired values are obtained to the desired degree of accuracy. Now let us solve one problem using this method. Okay. Apply Gauss Seidal method to solve the equations 20x plus y minus 2z is equal to 17. 3x plus 20y minus z is equal to minus 18. 2x minus 3y plus 20z is equal to 25. Now first observe that these elements are large as compared to other coefficients, isn't it? 20 is greater than 1 minus 2. 3 ಮತ್ತೆ minus 1 again the 20 ದೊಡ್ಡದಿದೆ. Similarly, ಇಲ್ಲಿ 20 is greater than 2 and minus 3. So we have three equations in three variables x, y, z. Let us find x, y and z using Gauss Seidal iteration method. Now here initial approximation is not given. So choose x0 is equal to y0 is equal to z0 is equal to 0. Okay. So first step, rewrite the equation. 20x is equal to 17 minus y plus 2z, or x is equal to 1 divided by 20 into 17 minus y plus 2z. From the second equation, 20y is equal to minus 18 minus 3x plus z, or y is equal to 1 divided by 20 into minus 18 minus 3x plus z. From the third equation, we have 20z is equal to 25 minus 2x plus 3y, or z is equal to 1 divided by 20 into 25 minus 2x plus 3y. Okay. Now let us begin the process. Let the initial approximation be x0 equal to y0 is equal to z0 is equal to 0. We substitute y is equal to y0 and z is equal to z0 in the first equation. Here this is 0, this is also 0. So we get x1, which is equal to 17 divided by 20, that is equal to 0.85. Okay. Then we substitute x is equal to x1. Now x1 is 0.85 and z is equal to z0, that is equal to 0. Okay. So most recent approximation is used here. So y1 is equal to 1 divided by 20 into minus 18 minus 3 into 0.85. We obtain y1. y1 is equal to minus 1.0275. Okay. Now calculate z1, which is equal to 1 by 20 into 25 minus 2 into x1. We substitute x is equal to x1. x1 is 0.85 plus 3 into y1. y1 is minus 1.0275 and we find z1, which is equal to 1.0109. Now in the second iteration, we substitute y is equal to y1 and z is equal to z1 in the first equation. So x2 is equal to 1 divided by 20 multiplied by 17 minus y1 plus 2z1, which is equal to 1.0025, right? Substitute x is equal to x2, z is equal to z1 in second equation. Second equation, put x is equal to x2 and z is equal to z2 to obtain y2. So we get y2 is equal to 1 divided by 20 into minus 18 minus 3x2 plus z1, which is equal to minus 0.9998. Put x is equal to x2, y is equal to y2 in the third equation. We get z2 is equal to 1 divided by 20 into 25 minus 2x2 plus 3y2. Substitute the values and simplify. We get 0.9998. Now compare the values. x2 is 1.0025 whereas x1 is 0.85. y1 is minus 1.0275. y2 is minus 0.9998. So the values are not same. We continue the iteration process. So in the next iteration, we put y is equal to y2 and z is equal to z2. In equation 1, to get x3, which is equal to 1 by 20 multiplied by 17 minus y2 plus 2 into z2, which is equal to 1.000. That is 1, isn't it? So putting x is equal to x3, z is equal to z2. In equation 2, we get y3 equal to 1 by 20 multiplied by minus 18 minus 3x3 plus z2 is equal to minus 1. Put x is equal to x3, y is equal to y3. In equation 3, we get z3 equal to 1 by 20 multiplied by 25 minus 2x3 plus 3y3 equal to 1. Okay. Now compare the values. See, x3 is 1. x2 is equal to 1.0025, which is practically same, isn't it? y2 is minus 0.9998. When you round off this number, we get minus 1. Similarly, z2 is equal to 0.9998, which is equal to 1, almost equal to 1. So we stop the iteration process because the values in the second iteration and the third iterations practically being the same, we stop the process. Therefore, x is equal to 1, y is equal to minus 1 and z is equal to 1. So this is Gauss Seidal iteration method. See here, convergence is faster. Gauss-Jacobi iteration method same problem ಅನ್ನು solve ಮಾಡಿದ್ರೆ ನಾವು 6 iterations ವರೆಗೆ ಮಾಡಬೇಕಾಗುತ್ತೆ. So convergence in Gauss Seidal iteration method is twice faster as compared to Gauss-Jacobi's iteration method. So ಈ ಮೆಥಡ್ ಅಲ್ಲಿ ಏನು ನೆನಪಿಟ್ಕೊಳ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಈಕ್ವೇಷನ್ಸ್ ಕೊಟ್ಟಾಗ ಈ ಕೊಯಿಫಿಷಿಯನ್ಸ್ ಉಳಿದ ಕೊಯಿಫಿಷಿಯನ್ಸ್ಗಿಂತ ಲಾರ್ಜ್ ಆಗಿರಬೇಕು. These coefficients are large as compared to other coefficients. ಅದನ್ನೊಂದು ನೆನಪಲ್ಲಿ ಇಟ್ಕೊಳ್ಬೇಕು. ಒಂದು ವೇಳೆ ಅದು ಲಾರ್ಜ್ ಆಗಿರದೇ ಇದ್ದರೆ, ದೊಡ್ಡದಿರದಿದ್ದರೆ, ನಾವು ಈಕ್ವೇಷನ್ಸ್ ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಿ ಈ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಉಳಿದ ಎಲಿಮೆಂಟ್ಸ್ಗಿಂತ ಡಯಾಗ್ನಲ್ ಎಲಿಮೆಂಟ್ಸ್ನ ಕೊಯಿಫಿಷಿಯನ್ಸ್ ಉಳಿದ ಎಲಿಮೆಂಟ್ಸ್ಗಿಂತ ದೊಡ್ಡದಿರುವ ಹಾಗೆ ನೋಡಿಕೊಂಡ್ರೆ ಆಯಿತು. ದೆನ್ ವಿ ಅಪ್ಲೈ iteration method. Okay. So I hope you have understood Gauss Seidal iteration method. Reference book is Numerical Methods in Engineering and Science with Programs in C and C++. Thank you.